Good evening. Welcome to the QCIS channel. We're on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones. Tonight, I have a good one for you. I'll talk about mathematical problems in construction. Now, I work as a project manager for the city of Indianapolis, and I go out and inspect infrastructure, roads, bridges, pipes. Now, you have to get quantities on some of these materials so the contractor can get paid based off the quantities that they bid. Now, one thing that inspectors don't understand is how to do the math. Now, the math is very simple, but there is some trigonometry behind it. Now, you don't have to use any algebra, but you need to know how to convert gallons to pounds, ounces, you're using liquids or stone. You need to understand lengths, which you're going to deal with linear feet. You need to understand area and volume, which you may have to convert cubic inches to cubic feet, cubic yards. Same thing with square inches, square yards, square feet. Well, this video that I am presenting to you, I've already worked out all of the problems. Now, I'm going to explain to you how I got the answers. You should take notes because if you want to be a good inspector in the field, you need to know how to do the math. Now, I'm going to go ahead and actually share my screen. And you can see the numbers. Now, this is all of the work that I have done. And I'm going to share it with you because in the field, you're going to see these problems. And when you write your report up as an inspector, the person that's going to be auditing your work may want to see how you came up with your solutions. So let's get into it. Number one, when we deal with something triangular, and we have to utilize perimeter, what are we doing? Well, we're adding up all the sides. So basically, when you have a triangle and a square, the difference between a triangle is basically half of a square. That's why a triangle is 360 degrees and a square is 360 for a square, 180 degrees for a triangle. That is 180 degrees for a triangle. Now, there are different types of triangles. There's scalene triangles, there's equilateral triangles, there's right triangles. But the one that I'm talking about, if you want to get half of a square, then we talk about a 60-60-60, which is an equilateral triangle. However, when it comes to the problem, let's get to this first problem, and I'm going to show you how I got the answer. Now, for number one, a triangular frame has three sides that measure 15 feet 7 inches, 20 feet 4 inches, and 26 feet 2 inches. Well, what is the total length of each side? Now, how I did it, now I'm an engineer. I generally do not use inches. I use tenths of a foot. But for this problem, I use inches. So what I did, I took 26 feet 2 inches, added it up. I took two sides, make it easy for me. Added it up. I came up with 46 feet 6 inches. That's two sides. Now the third side of the triangle, I added up to the sum of the first two angles I got. So I took my 46 feet, 6 inches, and then added 15 feet, 7 inches, totaled everything up. I got 62 feet, 1 inch. Now, we know 6 and 7 equals 13 inches. But I know that I'm going to have to basically add an additional foot to these two numbers out here, because 13 inches is basically 1 foot, 1 inch. So 6 and 7, I got to 13. So I have the 1 inch down here. So I carry that extra foot. So I have 7 and 5. That's 2. I add another foot. That's where I got the 62 feet, 1 inch. Next problem. A carpenter has a board of 2 feet, 10 3/4 inches. To fit the piece, or to fit the space for a shelf, the carpenter cut 7/16 of an inch off one end. How long was the board after the piece was removed? Well, basically, all I did with this problem, I just took 2 feet, converted everything. I actually took 10 3/4 inches, put it all in 16ths. The reason why I put it all in 16ths is so when I do fractions, I have a common denominator. So I took 10 3/4 and put it in 16ths, and that's where I got the 172 16ths over 7/16, and it made my subtraction easy. And then after I did all of the subtraction, I then converted my inches to basically tenths of a foot, and then I converted that into regular inches. So this is how I came up with 10 and 5/16. Now again, if you have a blueprint book, you can find all of these mathematical problems. Now this math is very good if you're going to be a carpenter. You need to cut the boards correctly in order for them to lie flush, especially if you're putting joists or studding in for framing. Now, next problem. 15 strips, 1 1/4 inch wide, are to be ripped from a sheet of plywood. So if 1/8 of an inch is lost with each cut, how much of the plywood sheet is used in making the 15 strips? Now, assume 15 cuts are necessary. So what did I do? Okay, again, I have 1/8 of an inch. So I have 1 1/4 of an inch. So what did I do? Well, I converted 1 1/4 of an inch to 1 2/8, which is still the same as 1 1/4 of an inch. Why did I do that? So I would get a common denominator to make it easy for me to subtract the difference, because what I'm subtracting is in eighths. But what I have in my width is in fourths. So to make everything simple, I took, again, the 1/4 of an inch, and I changed it to 2/8. So I have 1 2/8 of an inch minus 1/8 of an inch, and I get 1 1/8 of an inch. Now, remember, I have 15 strips. So here's what it is. You have 1 1/8 of an inch times 15 strips, which gives you 16 7/8 of an inch. Now you remember, one strip is 1 1/8 inch wide. So it's 16 inches. So what I did, I took 1, and then I took 4 7/8, and I got 1 foot 4 7/8 of an inch. Now, what are they asking? They're asking what is lost. So overall, what we have here, and hold it, let me go back here. That's the next problem. Let me stay up here. Although I do have the problem right. It's 1 foot 4 7/8 of an inch is lost because I have 15 strips. And I have the number right here. So this is how I got all of my mathematical problems. And in construction, you're going to do it. Like I said, if you're in carpentry, you're going to have to be understanding of inches. So you're going to use quarters, you're going to use eighths, and you're going to use sixteenths. It's very popular. Now, in engineering, like myself, I'm going to use tenths of a foot, like 6/12. I would call it 0.5, which is half of a foot. Now, all of the work is done. Again, 1 1/8 of an inch times 15 strips gives you 16 7/8. So one strip is 1 1/8 inch wide. But again, they want to know how much is lost. Well, basically you have 1 foot 4 7/8 inches, 16 inches. You have 16 inches, and up here, 1 foot 4 7/8 inches. Okay, an interior wall of a building is made up of metal studs with 5/8 inch gypsum board on each side. See the drawing below. If the actual width is of a stud is 3 5/8 inches. Again, we have a gypsum board wall, which is basically 5/8 inch. It's gypsum board, and that's on each side, according to this picture. Now, here's your gypsum board on each side, 5/8 of an inch. Here's the stud right here. So if the stud has a width that is 3 5/8 of an inch, what is the thickness of the wall, the total thickness? So again, when you're doing problems, you want to make sure that you write down all the information that you're given. So the stud is 3 5/8 inches thick. The gypsum board is 5/8 inches thick. Now you have two. Now remember, you have two gypsum boards on each side. So you're going to have to add both of those up. So what I did, I got 10/8. Some mixed fractions. So I came up with, of course, 1 2/8. Now, what is the thickness? The actual thickness of the wall. Well, I'm going to add the stud plus the gypsum board on each side. And I come up with 4 7/8 of an inch. Remember, always a common denominator. This is basic math. Again, your gypsum board, it makes up for your wall, but this is the whole wall, including the gypsum board and your studding. So I came up with 4 7/8 inches. All right, something else you need to learn. This is construction math here. I did a video earlier on construction math. I didn't work out any problems. So I'm giving you problems that I've actually worked out. Now, if you are a foreman or a superintendent, you're going to have to do time for your laborers. So here's one that involves time. A carpenter worked 10 weeks on a particular job, 5.5 days per week, and 7 3/4 hours per day. How many hours did the carpenter work on that job? So 10 weeks, 10 weeks. So 5.5 days. So how many hours? So what I did is I took weeks, 10 weeks by 5.5 days. Now I wanted to get days. So I converted the 5.5 hour days because they're working in weeks, 5.5 hour days per week. So I took that information, took the days. 1 week equals 5.5 days. This is working days, not calendar days. So once I converted everything into days, I got 55 days. Now I had to take the days and then convert the days into hours because the carpenter worked 7 3/4 hours per day. So 7 3/4, which is 7.75 hours per day. So now I multiply my 55 days times my hours. After I convert, I get 385 hours. Very, very simple. Have to understand conversion factors. Number 6, this is one of my favorite ones. What is the area of a rectangular floor that is 7 feet 3 inches long and 4 feet 2 inches wide? Now, normally on an engineering case, I would convert these inches into feet, tenths of a foot. And that's exactly what I did. 7 feet 3 inches, 7.25 inches. 4 feet 2 inches, 4.167 feet. So when you take everything together, feet times feet gives you square feet. So I multiplied everything together. That's what I got. Length times width is your area. I came up with 30.21 square feet. And this is what you're going to see in the field if you're doing road work. Now, this is what we call a stair problem. All right. There are 15 risers in a set of stairs running from the basement to the first floor. Each riser is 7 feet 1/4 inches high. So what is the difference between the floors? All right. Here's what I'm going to tell you. All right. I took 7.5 inches times 15 risers, and I got 108.75 inches. So I wanted to convert everything to feet, and I did. So I got 9.0625 feet. So what I did is 9.065 feet. I took the 0.65 and then I multiplied it by 12 inches because what I did, I converted feet back to inches because I already got my 9 feet here. Basically, I took this decimal and broke it down into inches. That's how I got the 3/4 of an inch. So I have 9 feet, 3/4 of an inch. That is the difference between both floors. Again, I took the risers in inches, multiplied it by the number of risers, which gave me inches. And I took that and divided it by 12 to get feet. And then I basically took the 0.0625, multiplied that by the 12 inches to get 3/4 of an inch. 0 feet, 3/4 of an inch. So put everything together. I have 9 feet plus 0, 3/4 of an inch, which is basically 9 feet, 3/4 of an inch. And that is the difference between both of the floors. Going back to number 8 here, the distance between two floors is 9 feet, 1/2 inch. So if 14 risers are used in a set of stairs, what is the height of each riser? So I have 14 risers. So basically, again, I took the 1/2 inch and converted it into feet. And then I added it to feet. And then what I got, 9.4167 times 12. I converted everything into inches and I divided it by 14 because I have 14 risers. All right. So I then got 8.07, took the 0.7 or the 0.07, and then note with 8 feet, 1 16 inches. Again, I just converted everything. That's all I did. Number 9, how many 1x2 shelf cleats 8 inches long can be cut from a 1x2 board 16 feet long, and how much is left? Got to disregard waste and a saw cut. So what I did, I took 16 feet times 12 inches. I got 192 inches divided by 8 feet, which gives me 24 cleats. Nothing is left. So I have 24 1x2 cleats that are 8 feet long. Very simple. It's conversion. Took feet. And now, because I knew 16 feet times 12, 1 foot equals 12 inches. And that's how I got the 92 over 8, and I got the 124. It's very simple. Here's one if you're going to be out in the field, you're dealing with cubic yards of earth. A contractor removed 357 cubic yards of earth from a building site. So if the contractor's trucks can haul 17 cubic yards per load, how many truckloads of earth were removed? Very, very, very simple. So basically, you look in the trucks. Now, most of the time, trucks are in tons, but here they're using cubic yards. So basically, all I did is I took 357 divided by 17, and I got 21 truckloads. So that means you need 21 trucks to haul 357 cubic yards of earth moved from a building site. Self-explanatory. All right, figure the amount of concrete in cubic yards required to pour a slab of the following dimensions: 8 feet by 24 feet by 4 inches. Now, what I did, I converted 4 inches into feet and got 0.333. So I took 18 feet. Now everything is in feet. So now I have 18 feet by 24 feet by 0.333 feet, which gives me 143.8 feet, 86 cubic feet. Again, little conversion up here with the 4 inches. So where all of the units are consistent. So when I multiply all of the dimensions together, 18 feet times 24 feet times 0.333 feet, I come up with 143.86 cubic feet. Now, they're asking for cubic yards. So you have to know the conversion factor going from cubic feet to cubic yards. And it's 27. 27 cubic feet is 1 cubic yard. So basically all I did is I took 143.86 cubic feet, divided it by 27, and I got 5.33 cubic yards. And you're going to do the same thing here. You're going to take your feet and inches, because you have feet, and inches. So you're going to take your inches and convert it to feet, just like I did in number 11. And what did I get? I get 2,000.16 cubic feet divided by 27, and I got 74.08 cubic yards. They're asking how many cubic yards of concrete are needed to pour a slab 60 feet by 80 feet by 5 inches thick. So again, you take 5 inches, convert it into feet, get 0.4167. Everything is in feet. All of your dimensions, when they're multiplied, they're going to give you cubic feet. To get cubic yards, you divide by 27. That's where I came up with my cubic yards. Moving on to number 13. How many gallons of paint are required to paint one side of a block wall of the following dimensions: 6 feet by 172. The paint being used will cover 200 square feet per gallon. Okay, so I'm going to take my area, 6 by 172. Then I'm going to get my square feet. I divide it by 200 feet per gallon. And I have 5.16 gallons, which when we're dealing with paint, you round it up to the next gallon. So 5.16 is going to be for this whole room of 6 feet by 172. You're going to need 6 gallons of paint. Very important that you understand that, especially when you're estimating how much of this product is going to be on your project. Let's get to the next one. Number 14, compute the gallons of sealer required to seal a floor 120 feet by 250 feet. The sealer being used will cover 175 square feet per gallon. Same type of problem. Take your area and then you multiply it by your square feet per gallon to get the gallons. And you actually come up with 171.43. That's the actual number, but you're going to round it up to the next whole gallon, which is 172 gallons. Very, very simple. Now, if you are doing road construction, you're going to see this. How much concrete is required to pour the slab? So this is a funny shape, so you need to know your areas. So in this one, what I did, I took the area, which is the length times the width, and this is this rectangle right here. And then I took the area, half pi r squared for these semicircles. So first, I took 10 centimeters because I want everything to be in meters. So I converted 10 centimeters and I got 0.1, and that's the thickness. So you have two areas right here. So the first area is a rectangle, and I have 12 meters going across. Now, how did I get that 12 meters? Because when I'm dealing with the semicircle, I have this would actually be a radius and a radius, and that's where I got the 12 meters. So for my first area, I'm going to take 15 meters times 12 meters, and I get 180 meters square. So for my next area, I'm going to have 1/2 pi 6 meters, which is pi r squared, and I'm going to get 56.55. Now I could have added the semicircles together, but I did them separately, so I had 3 different areas. So I added all of my areas up. This is where I got the factor 293.10 square meters. I believe in taking, if you have a problem like this, to make everything work properly, I'm gonna work each area separately. That way you can't go wrong with your math. So I took the rectangle, and you need to know the formulas. And then I worked on the second area. I called it A2. You see up here, I label everything, A1, A2, A3. That keeps everything organized. Because the areas, you're going to use 2 different formulas. You're going to use a formula for a semicircle, and you're going to use a formula for a rectangle. And then you're going to add all the areas together. And in the field, when they're pouring concrete, let's say this looks like it would be an island, a concrete island. Well, you're going to have this type of equation. And if it were a quantity, this is what you would pay the quantity. And the unit would be square meters because it's area. All right, then we get another one. We're dealing with ceilings. And what did I do with the ceilings? Walls and everything. Showed you different areas. Ceiling, so for A, I took a wall 1375, multiplied by 8. I got 110 square feet. Then I took another wall, 12.33 by 8, and I got 98.66 square feet. And then what did I do? High ceilings. I subtracted the ceilings, and I also subtracted the windows, and I got 179.66 square feet. Did the same thing for the next one. Sometimes you have areas and then you're going to have to deduct something like a window. Window is 21 square feet. Same thing I did here. Talk about how much paint you're going to be using. The same thing right here. What they want you to do is how many lineal feet of cove-based floor trim will be required. And you're dealing with paint. And so you get all the answers. For this one, you're dealing with a concrete column here. You're going to take your inches, convert it into feet. Then you're going to take you have inches and convert those into feet. And what are you utilizing? You're utilizing volume. Always write your formula down. You plug all of your numbers in. And then you're going to get your cubic feet. You divide it by 27 to get your cubic yards. And this is approximately 2 cubic yards. What is the circumference of the shape? Again, convert inches to feet. Utilize a formula. You plug everything in. Get 39.01 feet. For this one, what is the total lineal distance in feet along the curve shown, and round off to the largest foot? So you have your arc length. You deal with angles here. You get your feet, next largest foot, 20 feet. Then you have your 10 feet, 6 feet, 20 feet, 4 feet. Then you get 40 feet. This is your lineal feet of curve right here. Now remember, I had angles right here. So I took that 10 feet. That's my radius. Then I took the angle. 110 over 360. Why? Because it's 360 degrees in a full circle, but I have a partial circle. And I utilize my radius. This is how I came up with the 19.19 feet, which you have to, again, round it up to the next foot. So you have 20 feet. So you put everything together, 10 feet, 6 feet. Then you have this area, now it's complete, that's 20 feet plus 4 feet, and that is 40 feet. Same thing that you do here is a bunch of areas. Like you start off, area equals pi r squared. Again, you see how I labeled it? You have different areas up here. Starting with, let me see, A1, pi r squared over 4. So 1257. And what are you going to do? You're going to add each area up. So you're dealing with sidewall. So you must know all of your formulas. And then once you get your areas, you total them up. And that's exactly what I did here to get 119 square feet. Now, sometimes you may have a missing dimension. Well, it's very simple. If I have 30 feet for the total length, and I have 15 feet here and 9 feet, well, A, what's the missing length? So I can do this in my head. I know we have 6 feet missing. Because 15 plus 6 is 21, and 9, that equals 30. Find the missing dimension. These are architectural plans. You do the same thing. You add everything up, you get the total. You can find it here as well. So the total what we have is 1810, and you put everything in there. 10, you get all of these dimensions, and they should be equal. You're going to find this on a lot of your architectural plans, just like you're going to find this on the architectural plans. And you do the same thing here. Find the missing dimensions in the string. So you already have your overall dimensions. So you have 75/8. So what it is here. And basically, to get this dimension, you just subtract this dimension from your overall dimension, and that's how you do it. Well, you can do the same thing here. You can add these two dimensions up, subtract them from your total dimension, and you get this dimension. And going back up here, you would do the same thing. You have all these dimensions, you add them up, you get 18 feet. 18 feet 10 inches. Once you add all these dimensions up, well, to find A, you would take your overall dimension and you subtract the known dimension to get the unknown. That's how you do it. Very, very simple. Find the missing dimensions. You're going to do the same thing here. Same thing. Find up the total dimensions. This is all the work I've done for you. Let you all look at it. And then you're going to find the area of a partial circle. It's just knowing what you're given. You're already given your radius. Generally, what I do, I convert everything to feet. So I have my area of my sector. So what I did, I have theta over 360. What's my theta? It's 155 over 360 times pi times my radius squared. And that is my area of a partial circle. It's one of my favorite ones too when I'm out in the field. What is the area of a trapezoid? Well, first of all, get all your information. Get A, because the area of a trapezoid is your area equals, I call it base A plus base B divided by 2 times your height. So you have your two bases and you have your height. You divide your two bases by 2 and multiply it by your height. And then you get your area. Your area is always in square feet. Find the volume of a triangle. Again, 1/2 base times height times length. You get everything that is known. You write your formula out as well. And then you plug all of your known information into your formula, compute, and you have your answer. That is your volume. As you see, I have the formula, I have all my information so I can put it in my work to get the answer. And that's basically how you solve mathematical equations for construction. And you can find that information if you really want to know where I got it. It's one of the courses that I took at Ivy Tech. That was my plans reading course. If you go to Ivy Tech, take BCOM 102. That's a construction plans reading class. You will see those mathematical formulas in that book. And that book is very, very useful when you are dealing with construction, especially if you want to be an estimator. And some of that information also goes with information if you're out there as a construction inspector when they're pouring concrete for curb and gutter, sidewalk, they're doing asphalt, they're hauling earth material off the site. And you can also, with the information, learn how to convert feet to inches, cubic feet to cubic yards, square feet to square yards. And that's this presentation on mathematics for construction. If you like what I just presented, please comment, share, and subscribe. Now, if you want some political or social content, check out my main channel, the 411 Talk Zone Radio Show on YouTube. Now, I'm going to go into every area where you can find me. So for the 411 Talk Zone Radio Show, you can find me on YouTube. You can find me on Twitter, which is X. You can also find me on Rumble and Truth Social. All the information is going to be the same. So when I record a video on YouTube, same video is going to be up on Rumble. The same video is going to be up on X. And the same video is going to be up on Truth Social. Now for the QCIS channel, I do the same thing. Except I don't use Rumble or Truth Social. But I do use X for the QCIS channel. And I also post all of my QCIS videos up to my LinkedIn page. And again, thanks for listening and viewing this content on mathematical problems in construction from the QCIS channel. Well, on this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.